this first set of notes, a couple people came in and they were like, this looks familiar. Yes, this whole first page you already did. Okay, you did these on Thursday before break. But before you put an X on it, you should have recognized that if we are adding or subtracting something from x squared, what does it do? This is going to be a translation up or down, that many, right? It's essentially your C is your translation, because if you think about it, this is really our HK, right? So if I have this particular equation, right, and our HK, remember, is A times X minus H quantity squared plus K, then really what this equation is saying is, and I know that you wrote something else here, but Y equals, your A is 1, X, we don't have an H, so technically 0, squared minus 4. Because when you're telling me what is the vertex where it crosses the y-axis, the vertex for this is 0, negative 4. Do you see that? So really, that plus or minus piece is your HK, that translation piece. And because K is just your up, down, that is why when we add or subtract something, that's what's happening. Does that make sense? So we did a little practice on that before the holiday. But what we're going to, so you do not need to do the top of this, okay? We've already done it. But I wanted to reinforce that because I had a couple people who weren't here. Where I want you to start is here at set C. Okay? Now set C is all about A, right? Our first example that we did last before break, we were talking about C, right? That constant. Okay, today we are talking about A, and A, remember, is ax squared plus bx plus c. So today is all about A. Now, what I want you to do is I do want you to graph these. So we're going to do a little bit of graphing together. So if you would go to your calculator. Okay, and do we remember what this y equals x squared is called? It has a special name because it's a special equation. Do you remember what it's called? Very good. This is the parent function, and you will see that again. This is the parent function. So when we put that in, that's the one that all of our equations are based off of. And you can see here it is going, if you could even do control T, right? You can see 1, 1, 2, 4, 1, 1, 2, 4. Which is that counting piece I showed you on the warm-up. So what do you think is going to happen when we put in 2x squared? Don't put it in yet. If you already put it in, don't say anything. What do you think is going to happen here? Our vertex is 0, 0, yay. What do we think is going to happen here? Nobody sure? What do you think? You know? Tell me. It does. It's going to get, not smaller per se, but it's going to get narrower. Right? I want you to notice, right? It still has a vertex at 0, 0, but it got narrower. It got skinnier. Okay? And the reason for that, if we come over here to the graph, right? If I'm doing my parent function, we said that A here was 1, right? So it's like slope, up 1 over 1, up 1 over 1. You could even put in a 2. If we put in a 2, we get 4. 1, 2, 3, 4, right? 1, 2, 3, 4. So this is my parent function, right? When I look at this, if my slope is 2, I'm going up 2 and over 1. So as it gets, so it's going to get, that's not a very good line, but you can see that it gets narrower. Do you see that? What do you think is going to happen on the 5? It's going to get even narrower because now we're counting up 1, 2, 3, 4, 5, and over 1. And you can confirm that on your calculator, right? Your vertex hasn't changed because there is no C. All right, does everyone see that? And you can, again, you can confirm that here. So it's just getting narrower, whereas before when we were talking about C, then it stayed the same amount of narrow, right? It stayed the same width, it just moved up and down. Okay? So what do you think is going to happen on these? They're going to get wider. So if I did 1/2, I'm still starting at my origin. Now I'm going up 1 and over 2 instead of up 2 and over 1, right? So you can see that it is going to get wide. What do you think is going to happen here? Up 1, it's going to get even wider. 1, 2, 3, 4. All right, and then this one, we ran out of space. It's like way over here. Super duper wide. And you could even put those into the calculator to verify it, right? We could say 0.5 x squared. Look at that. It's this purple one. Bless you. I could put in 0.25 x squared. There's the green one. And then you can say 0.1 x squared for 1/10. And it's super duper wide with the red. Do you see that? So what I want you to take from this as far as what happens with A, what effect does A on the equation y equals ax squared have on the graph? So A controls width, right? And we can say if A is less than 1, it got what? Wider, right? Which is backwards of what you would think. Until we start graphing it, then it makes a little bit of sense. If A is greater than 1, then it's going to get narrower, right? Not necessarily smaller, but narrower. Okay, so that's what I want you to take from this today. Now, there are a couple more for you to practice on. This one has a positive and a negative. This one has a mixture of things. This talks about what happens with a negative. When you get down to 15 here, I don't want you to sketch it. I want you to write in words what happened, right? So what happens when there is a negative? What happens when A is 1/17? What does that 1/17 do? What does the +8 do when you graph it, okay? So kind of like when we were doing shifts and we said it went up 2 and left 5, right? So I want you to write it in words like that. And then when you get to the back, the A effect, this is based off an old calculator. You don't need to do anything here. I just want you to graph your equation. Tell me what A is. Do Control T, and you can fill in your table and then make your graph. Okay? This is just showing you what it would look like when you put it in the calculator. After you do that, then you can work on that practice homework page, which shouldn't take you very long to do. Does anyone have any questions? All right, let's be amazing.